All right, welcome everybody. We are here, we're starting, and right now we're just going to quickly review some of the concepts of last week and just make sure there's any questions. There is a pop quiz that I've enabled. I think it's going to open around 7:10. The window will close around 7:30. It's only 5 minutes and the clock will be ticking as soon as you start it. 4 questions. This will probably be the last pop quiz you'll have to worry about. I think going forward we'll skip out on this. Um, and then tonight we're going to talk a little bit about the MLV, the managing the logical volumes and stuff like that, and get into a little bit of that. And then the next week's material as well, which we have another virtual machine that we'll have to log into. It's a bonus lab. Um, and we'll talk about that as well. It's similar to what we had to do the week before. Um, so again, were there any questions or difficulties with lab 10 or 11? Was it pretty straightforward? I know in lab 11 is where it was more focused on um, modifying the directories, the permissions of a folder or file of the directory, changing those around, verifying it. You may or may not have had these usernames, and if you didn't, you'll just create it and make sure that everything is running okay. I think I even demonstrated one of these in the last lecture video. So it's pretty good. Some follow-up questions, and that's pretty much it for those two labs. Um, the reading, let's take a quick peek at the reading real quick. I think I looked through several different of our Linux books. Hopefully you've downloaded them all. And what I realized was that this chapter 6 was pretty good. It was sufficient. And I think it's also a good resource for when you're ready to take that exam. So let's kind of skim through this real quick. Yeah, so we have the managing ownership and permissions. Let's just see if there's anything that kind of sticks out. Viewing the default file permissions and ownerships. Okay, so depending on your directory, you would hit that ls, and then the -l command just expands all the files and directories in the long format. And they also kind of talk about the structure of what each row really means. The permissions are on the far left, and then it just goes on and on from there. Talks about the user, the group, the amount, how big the file is in bytes and whatnot, the last time it's been modified, the name of the file. And you should be able to tell the difference between files and directories by that first kind of um, letter or dash. Pretty basic stuff. Here's another one. Using the change ownership command versus the change group command. So you talk a little bit about that. Managing the ownership from the command line. Let's keep going. This is pretty straightforward. Good stuff. There's a few exercises. You can decide to do it or not. And for the most part, I think everybody kind of got through this fairly well. Now, I do recognize that because most of us have our own setup and we didn't buy into the whole lab thing, they would have had everybody pay like close to $100 just for one semester. Um, that to me, it's just not in the spirit of learning Linux. But the drawback is that we're kind of all on our own kind of flavor, our own kind of souped up system. So, what one person might have in their system, another person, the person next to you might not have. So I'm trying to make sure that the labs are kind of calibrated so that anyone that's running Linux can pretty much get through it. You might have to download one or two things, but then for the most part, um, you have a fighting chance of executing all the commands. And then also, as always, at the end of the chapter, read through these questions, try to answer them, read the answers as well. That's always a good thing to do. And then that's going to help you with the quiz and stuff like that. All right. All right. So now, I guess if there's no other questions about that, we'll move into taking the pop quiz for chapter 6. All right. So let's just take a quick peek at that real quick. Okay, so it does open. Make sure you click next to get to the next problem. If you hit submit, then it's gonna submit right then and there, regardless if you finished or not. So take a moment here, and what I can do is paste that link into the chat. Just to make sure everybody has it. Let me know if you cannot find it, or you don't have access to it. So we'll do that for the next like 10 minutes or so, 5 to 10 minutes, and then we can even kind of go over them and also move on to what we're talking about tonight. So pretty straightforward night for us, guys. Welcome. If you're just now joining us, we are all working on a pop quiz tonight. It's just 4 questions. I put the link in the chat. It's just based on the reading from chapter 6. If you have notes when you're reading, you can use your notes if you have to. All right, we'll go for another 3 minutes or so, and then we're just going to start our lecture on the volume. All right. We should be wrapping it up by now. I can check and see where we are on that. So I'll have to go through and grade the short answer part. We can also go over these too if you want. Um, I think the first two questions, let's see. Is everyone just about done?
I'm just working on the last problem right now.
Okay, perfect. All right. Yeah, let's take a peek at how we might have done. Let's see here. Let's preview these questions here. All right. So the very first question is, which permission, when applied to a directory in a file system, will allow a user to enter the directory? And what will we say here? Is it access control, write, execute, or read? It should be,
Execute.
it is to execute, absolutely. Um, that was actually that was a little tricky. Because it's like, well, wait, what are you actually executing? It seems like the natural response would be to read or something like that, just to give you access to view. But read really just means to view, right? There's no, I mean, it's kind of like reading is kind of like a verb, but in the computer sense, um, it's you can't really do much by reading. It's pretty innocent. But to actually go in that directory, it's execute. And here's another, and this comes from question one came from the book. Question one was one of the multiple choice questions in the back of the book. I think it was number 2 or 3. Question 2 is also in the book. It's like number 6. You need to change the permissions of a file named schedule.odt so that the file owner can edit the file, and users who are members of the group that owns the file can edit it, and users who are not owners and don't belong to the owner group can view it but not modify it. Which command would do this? And hopefully I got it right, because this might have been switched around. If not, I'll just correct it. But the correct answer is 664. So the combination of 664 will do just that. It will give the owner the group, but limit the others, because remember, each digit represents a specified group. And then this question, what is the difference between the change owner and change group? I mean, that's just it. Change owner is to change the owner. The change group is to change the group. And that's all I was looking for. Just understanding what these commands stand for will be able to describe the difference. I mean, if you went a little deeper in that, then that's great. But yeah, I mean, it's two different things going on there. And again, that is straight from the book here. As you can see, one of the questions here where we talk about using this versus using this. So it's a utility that changes the user or group that owns a file or directory. And when we use this, it's to change the group that owns a file or directory. So it seems like the change owner kind of supersedes the change group. I mean, it just seems like it's going to cover more. It's just a more powerful command. But again, they're both utilities, so they have options, and we can modify them in certain ways. And then that last question, let's see. So if we do the ls.l command and we see this, what does it tell us? Anybody want to take that? What would this tell us? It's kind of very rare to see something like that. Um, let's see if we can, let me check I think we created a file that had that. Let's see. Hello. That hello. Let's see if it has anything. Okay, it just says hello, but let's do an ls long command. So that hello doesn't have the full load. So we're going to change let's see if we could change hello to that. We'll do a change mod 777. And now when we do this, now when we see the hello file, it has the RWX, RWX, RDWX. And all that means is that the owner has read write executable, the group has read write executable, and the others have read write executable permissions. So it's just a fully wide open. All right. So now let's get into what we got to get into. We're going to move on to the volume lesson here. I'm talking about storage, administering storage. And I do recognize that this is a little tricky, like the lab for this. I'll walk through the lab, and I rewrote the lab a few times to make it a little bit more clearer, so that you can see what the commands are doing, and it's like it gives good notes. It just doesn't just tell you to enter this in, but it actually explains the commands as well. So it just serves as a really good review. And I also realized that a lot of people are on virtual machines, subsystems, and so we're not going to be able to fully modify the volume. So we figured out a way around that as well. So understand storage, deploy storage, manage storage, and then troubleshoot. So we'll just zip through this. The reading is pretty good too. We'll skim through the read as well. But there are many different types of storages on the Linux system, as you know. And some of the modern systems have the SSD. I'm sure some of you guys are pretty familiar with this. I know when I was building my computer, the guy convinced me because I wanted to game, and I wanted it to be fast. So I ended up getting I believe it's the SSD, and it's just a lot faster. It's smaller. The HDD is still around. Oftentimes some systems will have both. And I do realize a lot of people have their USB, the thumb drives, and all this other stuff. Those are also pretty good for security measures too. But a lot of people's machines, I mean, there's no need to harden certain systems if it doesn't have vital sensitive info on there. So most, it just depends on what your computer is being used for, what kind of dictate um, the kind of storage you'll use, and then also the security that you have embedded for your storage devices. I do know that some hard drives do have passwords. There's a way to set up, even in Windows 11, Windows 10. I'm pretty sure there's a way to enable your hard drives to have a password. Um, even during the startup screen or inside the operating system. I've seen that, but it's kind of tricky to enable that. And again, there might not be a point to do all that. Um, let's move on. So there are what's called the storage designs. We got a file storage system, the block storage, and then the object storage. Um, Pretty straightforward. Nothing too crazy there. Let's see. Yeah. Here's some more info. We got the traditional partitioning versus the LVM. Um, so the logic volume manager, and then we also have the traditional partitioning, places a single partition on a single drive. Um, and then the LVM aggregates the storage capacity from multiple drives. Um, yeah, I mean, yeah, it just depends on kind of, again, how much storage you have, how much, I mean, how do you want your information to be accessed? So nothing too crazy there, pretty straightforward. Storage interfaces. I mean, this gets to a little technical. The SATA, the SCSI, and then the SAS. So three different types, but there are different reasons why you would have one setup over the other. I mean, some of this is, like if you're working at, a government office, you're a Linux administrator, their setup is probably gonna be something along the ends of something extremely expensive, something extremely fast and flexible. Um, the types of partitions. Okay, so we have the master boot record and then the GPT. They talk about both of these. Um, okay, let's keep going. We have the RAID storage here. This is good. Single disk quotas. And then we have some questions, some review questions on storage concepts, like explain the key difference between the MBR and the GPT, how my quotas help sysadmins manage storage devices, or storage capacities on servers, and then do all RAID arrays designs provide fault tolerance. Yeah. Now these questions are come from the text. So as you're reading, you can have some of these questions in mind, and that'll help you kind of answer those. All right, let's get into deploying this storage. So there are certain commands that kind of help you manage all these things, and some of these commands your system may already have, but if it doesn't, then we'll just have to install certain things. Here's one. It's the LSSCI. This gives the device name, model, etc. Um, Now the question becomes, well, would every system have that, right? I mean, would you have to install that command or not? So it really just depends on what kind of system you're running. All right. Here's some more things. Once the drive is installed, it must be partitioned. This is the design. FDIS, parted, partro, partition, and whatnot. Let's keep going. So here's an example where they're displaying the partition information with this command, the fdisk command. Let's see if I. Let's do that. Yeah, I just hit my command, but it showed it a little bit. Let's see if I can. So again, this is my Windows subsystem for Linux. And so when I did the sudo fdisk in the long format of this, here's what I got. And they're telling me that it is a virtual disk, the units, the sector. Pretty good stuff. Okay, let's get through all of this. They do talk a little bit about mounting a partition. Unmount. Yeah, df command will display the device's free system. See that. I mean, this will display a lot. It has, well, yeah, it's just a lot of memory on, especially on my D drive. But when we look into my Linux subsystem, I mean, it has a lot of different volumes there. And just, yeah, I mean, some of it's used, some's not, but there's reasons why all those things are there. All right, let's get back to this. Here's another command, the du command, df. There is a way to automate the storage mounting. So it says here, you add the storage capacity configuration file so it mounts when the system boots. Yeah, I mean, there's just so much you can do. All right, and again, some of this we can't really do because of our setup and what we're on, like if we're on certain systems, but you can do as much as you can. All right, yeah, I mean, it gets a little abstract too. I think the book might be a little bit more helpful because it'll have images and kind of shows you kind of the abstractness behind the way the volumes are kind of stacked and how certain things, depending on the order in which they're placed, will kind of dictate how you're going to access the certain materials. So here's a graphic with the layers here. So you got your physical volumes, the volume group, and then you have the logical volumes. That's pretty interesting though, when you think about it, right? So all your three of your volumes are going to be connected. So this machine has like three, but then they have formed a volume group. And then from the group, they have now created these two logical volumes. So you might have things in one volume that is just split between the physical volumes. Um, yeah, I like this. This is a nice picture. It doesn't always happen this way. With let's say you want to add a volume, it might just be mounted separately as its own drive. And then the group is just you don't necessarily have the group. They're just different. They're like disjointed. Um I used to have a dual boot. I mean, this machine it still has it, but I, I had one I just lost it because the uh the grub, like the startup got messed up. So, but basically when I turned on my machine, it would fire up and then it would ask, it would say, hey, which operating system do you want to use? And then you choose the one you're using and then you're in. And depending on how that one's set up, it may be linked to an entirely different volume too, depending on how you set that up. But now I realize you don't have to do that anymore. You can just use a virtual machine and it's less likely to become an issue, because you just have more control over it. And if something goes wrong, you can just erase the entire thing. So they're discussing some of the benefits of having this type of LVM setup. Yeah, I mean, it makes sense. I mean, you know, the logical volumes can exceed the size of one of the physical devices. Yeah, we saw that. We saw that in one of them. One of them was 10 TB, and these guys don't necessarily have 10 TB. So what if you want to have all your movies on one drive? The huge database of movies. Like you have some kind of theater or something, right? Like you might need a logical volume that can just access all of them from one set location. I don't know. It just depends on what you're trying to do and what the job entails. All right, and we will get to. Oh yeah, yeah. Some of these questions are really good too. Like let's see if I can. Um, Basically the dev folders I mean we all know that the dev contains the devices, and then the SDC indicates the small component computer system interface. And even that little three there, that signifies something as well. That just lets us know that it's part of the third partition. So we could go in there and kind of see what it would look like. there could be several different types as well. So, what role does part probe command play in the process of adding storage? And the note there is that part probe is just the command used in Linux to inform the operating system that the kernel partition changes. Um, what command add, oh, and the other thing is hey, why is that even needed, right? So when you modify the partition table of a disk, the kernel needs to be aware of the changes to correctly recognize the new partition. It's pretty interesting. The part probe will scan all the available disks. What command adds the XFS file system? And that's going to be the makefx fs command. Yeah. So pretty straightforward. What is a mount point? A mount point is a directory in a file system where the storage device or the partition is attached and made accessible. So that the mount point integrates additional storage into the existing file system hierarchy. And another thing, what are the three layers? We have the physical volume, the volume group, and the logical volume. We kind of seen a graphic of that. And we also saw some of the benefits of that. It's basically the flexibility and scalability. Yeah. And we'll talk about that lab, and we'll cover this one as well real quick. Let's just kind of run through this. So the rad summaries here, right? So the disk stripping, so speed increase, less data written to each drive, and it reduces the fault tolerance. The failure of any one of the drive results in all the data being unusable. So you got to have at least 2 disks. This is pretty interesting. So we have layers on data, and it looks like they're like divided in such a way that we have 1, 2, 3, 4. So it's kind of going back and forth between the different datas, and it's all embedded into this. Here's another setup. They call it disk mirroring. So the speed increase for reads either disk services than the read the call. That's good. Still requires 2 disks, increases the fault tolerance. There's another setup. Another one. And this is kind of taking us, I mean, you know, almost all systems will have this, it's kind of taking us outside of our Linux admin, but I guess it's somewhat important to see this so that we'll know how to influence it when we're at the command line. So here we have 2 clients, the Ethernet switch, NAS device, server. What is SAN? Here is the storage area network. Here's the graphic of that. This looks pretty crazy. I mean, there's just so much going on here. But it seems like almost everything is somewhat interconnected. We have the 2 different clients. They're connected to the servers through the different switches. And then we have the channels. We'll kind of push out where we're going to go next. And both of the servers are connected to the two different channels too. And then we have the RAD storage, tape storage, optical storage. Pretty interesting stuff. The last little bit is dealing with the troubleshooting of the storage. And then what we'll do is discuss the lab. So here, you know, they do have some commands where you have to access some of the storage information to kind of see what you have, the setup and whatnot. Another thing they're saying here is that the servers will need to be shut down carefully, especially if they're older. Pretty straightforward. I mean, this is all basic stuff. You know, I mean, if they were to ask you this, if you're taking that test, like the Linux administrator test one day, I mean, it's all basics, right? I mean, you know, you're not gonna, you know, if they ask you, hey, how do you shut down a machine? You know, you're gonna, hey, carefully, step by step, and um, device issues. You know, sometimes you got to check if things are plugged in. I mean, it could be a lot of things. I mean, you know, confirm that Linux detects the device, display partition, confirm the file system with the file system tools. Pretty good stuff. All right, so let's take a look at the new lab for this week. So it's managing logical volumes with LVM. So we're going to kind of simulate this. You may not have the LVM2, so you could just download it with this command. Well, these are two separate commands, actually. You might not have to update. You can update. Let's double check that real quick. Um, let's get this. Let's kind of walk through this real quick. Um, so as a systems administrator, your goal is to optimize the storage strategies using LVM, allowing efficient use of disk space and easy scalability for future needs. You will need to set up a volume group, assign physical volumes to it, and carve out the logical volumes for different types of data. So first, you may need to either update or just download this with this command. LVM2 is pretty quick. Since some people are using the Windows subsystem for Linux, the WSL like I am, and other VMs, they don't have direct access to the physical disk. So what I put in here, we'll use the loopback devices to simulate physical volumes. Hopefully you have this command, the DD command. It's used to copy and convert data. And so what you're doing here is they're creating two 100 megabyte files filled with zeros, and then DD is used to copy and convert the data. And here it creates empty images files to simulate disks. So these will be we'll create a group we'll assign these to the group, and then from the group we'll split it into two different to the LVMs. So here you'll do now if you just log in as root, then you probably don't have to use the sudo command. Oh, it doesn't matter. Let's see. So if I'm, oh, yeah, I want to do this. All right, so step 3, create the physical volumes. You will use the pv create command. There's going to be 2, loop 0 and loop 1. Confirm that they have been created. So they'll be listed out in this file somewhere, and then create the group. We'll call it backup. It's just all straightforward. I mean, hopefully it works for you. If not, if you have to skip a certain command, just skip the certain command. I don't want you to get too frustrated at this. It's supposed to go pretty smooth, but again, depending on your setup, anything could go wrong here. And you might have to troubleshoot, like figure out what you're missing. And then once we have the group, then you'll create the LVs, modify their sizes, format with the file systems, and then it's all pretty much downhill after that. So that's the big lab. You should be you shouldn't have too much difficulty with that. It's pretty straightforward. Let's see. Yeah. Yeah, I did some of these already, some of the commands. I got pretty far. And it was working out pretty good. Like I was able to create my disks images right away. And so that was good. And then you'll create your physical volumes. So that's pretty much going to wrap up this week. The other piece that I wanted to mention was just looking ahead real quick. So we're at week 7. I have week 8 already in there, but week 9 and 10 will be posted later on. Week 8 will be coming up, and we're going to have an introduction to Bash scripting, right? So we're kind of leapfrog a few of those other chapters. We just don't need them right now, and like this is another piece as well. So we have a lab, which is basically an intro to Bash scripting, which is pretty. I think you'll find it easy. You'll be using the text editor. You'll enter the information into the text editor, save it, change the permissions to executable, because by default it won't be, and then you'll run that command and see that it will do what it's supposed to do. It talks a little bit about, the if then statements, how to close it off, and some other functions inside of the shell commands, and Bash scripting has functions as well. But that's about it. Like I said, most of the code will be given to you. But the other optional lab, which we'll discuss next week, but it's the tough one. It came back. So for week 8, this is the level up challenge. I call it the bonus lab. It's worth 30 points, that's why. But you'll connect to this game. It's a different one, and it's a lot harder. Basically, you have to get to level 2. And what they say, the directions are to find the password somewhere. So search through the directory and find it. But after searching for it, what we realized is it's probably not anywhere. And so probably the way to actually advance to the next stage is to brute force your way. So you'd have to find where you're supposed to enter in the password. It's like a 4-digit number. And you have to brute force your way through it. And once you've done that, then you just send in proof that you made it to level 2 and you get the full credit. Now, I have code that creates a brute force script, bash script. And I wrote it in here. In step 6. So be vigilant for unusual named files and do a bunch of cat and all that. But if you don't have any luck, you can use brute force. You can brute force your way into the next level. There is code called brute force in the files section in a folder called code. So if you go to the files section and you go to a folder called code, there's 2 different files. One is the brute force where you can actually see the code. This, it won't open for you, but this is the file. They're both the same. It's just that this has the shell extension. So this will be the thing that you'll have to execute and run. But you gotta know where to run it at so that it will brute force, it will show the results and you will see the password and it'll work. But if you want to see the code and just type it in yourself, this is what the code will look like. I've tested this out. It worked for me. It should work for you. So that's the code that you'll have to run if you want to use it that way. But there could be another way to do it. I don't know, but this way will work as well. So there's the hint for that. Other than that, we're going to call it good tonight, guys. We're just going to wrap it up. If there's any other questions, you let me know, and also reach out throughout the week. Reach out to me through Canvas if anything pops up.